Hello everyone. Today we are going to talk about one of the factors or the let us say the KPI that is mostly used in manufacturing companies, which can always give you a picture of how your equipment and your industry is uh, effective and working efficiently or not efficiently. So that parameter is called overall equipment effectiveness. So to start with, so here what is OEE? OEE means, as we say before, overall equipment effectiveness, and it is one of the most important KPIs that is used by manufacturers. Um Mostly it answers the question, are we really using our plant production time productively? Are we really doing our production effectively without losses, or we are misusing the time that is given to us to produce? So usually it looks at machine uptime, machine speed, and product quality at the same time. Means that we are looking at having the machine up and running, and the machine runs at the highest speed, or let us say the line, production line, or and not or, and the quality is high. So that's where the concept of OEE comes from. Uh, we just want to talk a little bit about the history of OEE. So who started OEE? It was part actually of the total productive maintenance, and Seiichi Nakajima is the person who introduced first OEE between the 1960s to 1970s. It usually looks at reducing equipment losses, improving machine availability, increasing the productivity, creating a culture of always continuous improvement. So that's very, very important for all manufacturers to look at. And usually today we can see that OE is used mostly in FMCG manufacturers, fast moving consumer goods, because there we have a lot of pressure on producing on time, a lot of pressure on producing quantities, and one of these FMCG companies like tissue manufacturers, toilet tissue or serviettes, or these tissue paper manufacturers. Automotive is one of them, companies that is always looking at how effective are their lines, and of course other places like pharmaceuticals and other packaging manufacturers. So OEE is built on three main factors, as we said before. So it is built on availability, performance, and quality. So availability is looking at how much time the machine is actually running. If I'm giving you 8 hours, is the machine running 8 hours, or is it running 6 hours, or is it running 5 hours, or is it not running at all either? So most of the losses that can affect availability is the breakdowns, the changeovers, the waiting time, the lack of materials, or maybe lack of electricity sources, and other things. The performance factor, it measures how fast and performing is your machine. It runs compared to the designed speed. If I'm having a line, I bought a line and then they told me this line speed after experimenting is giving us 100 units per minute or 100 units per hour or whatever. So how much we are achieving or hitting that target of 100 units per minute? So that that usually gives you the idea of how much am I using the performance of my line. The line I'm using, is it moving to the highest speed? It's like we are having a car rated at speed of 200 kilometers per hour. How many times I have been really using this 200 kilometers per hour? So that's how we look at performance. We look at how much the machine, the line performing. It depends also on the equipment itself. The equipment, let us say, lifespan, how old is the equipment. So all this affects the performance, and usually the losses are reduced speed. Someone maybe managing the line is reducing the speed of the line, or minor stoppages in some places, or maybe operator is not efficient enough. So the third factor, which is also important, which is the quality of the product. So when I'm producing, how much am I getting rejects? Means at the end, when I'm producing and finishing everything, my quality of the product, is it the quality that is required? Is it within the standards that we are having? So in short, how much good products have been produced? And this usually is affected by how much defects you have as a losses when you are starting up, how much you have wasted on startup, and how much you have done rework. So here we are talking about combining A, P, and Q in OEE. So why OEE is multiplication, not addition? So let us go to the logical equations in mathematics. Usually when you are talking about combining availability and performance and quality, so the word and stands for multiplication in mathematics. So when we are interpreting logical equation or logical requirement from being logical equation to being mathematical equation, so we are talking about that I want a percentage that gives me availability and performance and quality at the same time. So these three factors, when you multiply them together, will give you the overall equipment effectiveness. And that's why OE is very strict and realistic KPI. It is very sensitive because in multiplication of the numbers between 0 and 1, usually the number reduces. So we have to be very careful on that. So here it's very important that you look at the graph that is now explaining exactly each and every factor and how it is being interpreted in the real life. So as we know, OEE is availability, performance, and equality. So when we start breaking down each and every factor of it, so we start with availability. I'm giving you a planned production time. How much you have used out of this planned production time is called the operating time. So the operating time is the time when the machine is operating and running, whether it's running at low speed, high speed, it is on. So availability will be the factor that is operating time over the planned productive time. For the performance, in that operating time, what was my actual output as units per hour? For example, I can say units per minute or whatever it is, as long as I'm able to measure it. So the performance is how much actually I'm performing as an output in units per unit of time, hour, time, or whatever, over the target. The target means I'm having a target of 100, 1,000 units per minute, whatever, how much I have reached out of this target. This gives you the performance. So the performance is affected by performance losses, as we say before, which is the performance of the operator either himself, reducing speed of the machine, small stoppages of the machine. All this affects performance. So coming down to quality is within this actual output that has come, in doing actual output units per hour during that time, how much I have produced. It's called total produced units, whether it's good or bad. So the quality now removes only the good products out of the total production that has been affected by the machine. So the factor of quality is good products over total produced. So doing now each and every factor alone, we can just give an example, like in availability. If I'm having, for example, 10 hours, I have a downtime of 2 hours, then operating time was 8 hours, then my availability is 80%. It means that the machine was available for production only 80% of the plant time. So if I go now to performance, we are having actual output over target output. So if the machine target was 10,000 units per hour, and actually I produced the speed of 8,500 units per hour, it means that my performance is 85%. So the machine was running slower than ideal speed by 15%. So if I go now to the quality, so if it is good products over total produced, it means that if I'm having, for example, 1,000 units, out of this 1,000 units, I have 5,000. If I'm having 100,000 units and I'm having 5,000 defective, so I'm having 95,000 units good. So my quality percentage will be 95%, which means that 95% of my production meets the quality standards. Why OEE decreases faster? This is very, very important for us to understand that when we are multiplying three factors, even if they are all of them 90%, the OEE will not be 90%. So if you multiply 90% by 90% by 90%, actually it's coming to 73%. That's very important to understand and to make others understand why OEE drops very fast. So because when you're multiplying numbers between 0 and 1, usually they reduce, they don't increase, or they don't give you an average. It's not an average, it's not an addition. So you have to make sure you understand this point, especially when we are talking about mathematical equation. So, and in that case, that's why I want to explain also in the next later on slides that what is now the world class and the average manufacturers that are the OEE for the average manufacturers. So coming to calculations, I want you to understand that OEE can be also calculated in a shortcut way. According to the equations we are having, if we are putting all the equations together, if we are referring all the equations and changing them into units, like for example, if I say availability is usually in operating time over plant production time, if I am reducing this and saying that I multiplied by the target output, then it gives me what is expected output during the operating time and what is the expected output quantities in units during the plant production time. In the performance is the same. If I'm having actual output over target output, if I'm multiplying that with the operating time, it gives me how much total produced divided by how much expected output during the operating time. And the quality, as you know, it's good products over total produced. So if I multiply three of them again, I can really reduce it into one factor, which is good products that are at the end of the production over the expected quantity on the planned production time. So we can minimize that by having only three parameters during production. If I'm getting these three parameters as data collection from the production floor, I'll be able to calculate OE, which is the plant production time, which is easy to know. Then what is your target output of the line? So if I'm having a line, I told you I'm running it at 10, I want to run it 10 hours, okay? My target per hour is 1,000. Okay, my good products that comes out, which means how much has been produced. It is also easy to get. If I get these ones, I just calculate and put in the formula down there. I can get OE easily. So now coming to this slide, which I told you about, is that what is the world class? People just ask who is now reaching the best. So world class usually is having difference according to the different factors of OEE: availability of 90%, performance of 95%, and quality of 99%. That is a world class company. So imagine for world class company, it is 85% of OEE. So it means that if you are at 85%, you are world class. If you are between 60 to 75%, you are at average manufacturing. And if you are below 60%, it means you need really to improve your manufacturing processes. So typically, manufacturers, in reality, if you are looking at someone who's really manufacturing and trying to improve himself, usually in average there is availability of 80%, performance 85, and quality of 92. That is now an average company that is now producing and manufacturing. In reality, that's just an example that you might also get in normal manufacturing environment, and that's why factories believe that we're performing well, while actually productivity losses remain high. So we have to be always conscious about what is happening at our manufacturing process. So what are the benefits of OE? Of course, when you are having OE, it helps companies to identify their hidden production losses, reduce downtime, improve machine speed, improve product quality, increase output without buying new machines. Because if you are having a line that is now working and you have already paid for it a lot of money, why we should be adding another line, adding space, adding workers, employees? At the same time, I can just perform with what I'm having. That one really reduces a lot of costs to the companies. So companies really look at having this OE calculated so that they can know what is going on in their line, and they can know they are within the average, above the average, or on the world class level. So it also improve the maintenance planning, because if you are really performing well at your line, you are having enough time to manufacture, so you'll be able to manufacture properly. You'll be able to have ample time to make sure that your machines are being maintained, cleaned, and maybe oiled, greased, whatever. It is like done autonomous maintenance or planned maintenance to it. It will not really affect a lot of production. So in just To finalize, we can say that OE is not a number, only it's a way of thinking. So what happened? It forces the manufacturers to ask why our machines are stopping, why our machines running slowly, what are the defects, why the defects are there, what's happening. And to know this, actually you can improve productivity, you can improve the cost, and you can be having reliability and competitiveness in the market. Thank you very much, and we hope that you have really benefit from this lecture about OE, and we hope that you will be able to also implement in your manufacturing environments, or if you want to study it as just something that you will in the future implement it in your manufacturing process. So we hope that this really helps you to understand and makes the environment for you, the production environment, a better place, cost effective. Thank you very much.